Antarctica, the coldest place on Earth. This seems a strange place to study global warming, but by drilling deep into the ice, scientists get vital clues to the Earth's past climate. It's part of the effort to answer the biggest environmental questions of our time. Is our planet getting warmer? And are we the cause? We all know that air provides us with oxygen, but until recently, few of us knew that the atmosphere plays another vital role. Without our thin blanket of air, Earth's average temperature would be minus 18 degrees Celsius, too cold for most forms of life. In fact, the atmosphere gives us a much more comfortable average temperature of around 15 degrees Celsius. How does this work? The energy that sustains life comes from the sun, mostly as visible light. Clouds reflect a small part back into space, but most is absorbed by the Earth's surface. Now here's the crucial point. The warm surface radiates energy back into the air, but as infrared waves, which have longer wavelengths than visible light. Most of this infrared is absorbed by air particles, and the net result is a warming effect on the atmosphere. So the atmosphere lets the light energy in, but traps the heat energy radiated back from the Earth's surface. This is the greenhouse effect. Does this explain how human activity could warm the planet? Not quite. We need to look a little more closely at air. It consists almost entirely of two gases. Nearly 4/5 is nitrogen and about 1/5 oxygen. Careful analysis also shows minute traces of other gases. One of these is carbon dioxide. It makes up only a few hundred particles per million. So which gases absorb infrared? Surprisingly, it's only carbon dioxide and some of the other trace gases. If carbon dioxide is a greenhouse gas, you'd expect that the more there is in the atmosphere, the more the temperature will increase. Climate scientists began regular measurements of atmospheric carbon dioxide concentrations in the 1950s at a weather station in Hawaii. As you can see, the levels have been rising ever since. Here are the average air temperatures for the same period. We can go back much further in time using indirect measuring methods. Is this dramatic increase due to natural processes or human activity? We need to look at what affects atmospheric carbon dioxide levels. Green plants absorb carbon dioxide from the air. Their leaves, nature's solar panels, combine carbon dioxide and water using the sun's energy to produce glucose molecules. This process is called photosynthesis. Phytoplankton do the same thing in the oceans using dissolved carbon dioxide. What happens to this carbon now locked up in organic molecules? Some is eaten by animals or humans who break it down to carbon dioxide and water, releasing energy. This is the process of respiration.